Hello, so today we are going to do this problem, which is part of Leetcode December Daily Challenge. So the problem is all paths from source to target. So we get a directed acyclic graph. So this piece is important, with nodes that are labeled from 0 to n minus 1. And we want to find all the possible paths from node 0 to node n minus 1. And we want to return those paths in any order. And the graph is given as a list of lists, right? And what this represents is basically that 0 has an edge, a directed edge from 0 to 1 and from 0 to 2. And here that there is a directed edge from 1 to 3 and here from 2 to 3. And these are not bidirectional, right? Because the graph is directed acyclic graph. It's directed, right? So you can see here we have 1 to 3. That's from this one. We have 0 to 1 and 0 to 2, which is from this one here. And then we have 2 to 3. And then for 3, it has no edge from it to anything. And so nothing here. And so what the problem asks us to do is to return all the paths from 0 to 3. Because n is equal to 4. And is the length of the graph, by the way. So we want to return all the paths from 0 to 3 here, because 3 is n minus 1. So we can go like this. So from 0 to 1 to 3, that's this path here. The other path is going from 0 to 2, and then from 2 to 3, and that's this path here. And those are the only two paths we have, so we return both of them. So that's the idea here. Now, how do we solve it? Well, it should be a pretty simple either DFS or BFS, right? Because we can just keep traversing until we reach n minus 1, append the path, and then keep traversing again until we get all the paths, right? So pretty straightforward, actually. Now let's first do it with BFS. I think it's easier, and then from there we can do it with DFS. So what we need first for our BFS is just a DQ, right? And we need to start from the starting position, which is for us is 0, because we want the path from 0 to n minus 1. And we can just pop from the front, right? That's what we do with BFS. And then the traversal for the neighbors. Remember, the index is the node, and the value is the neighbors, right? So for a node, to get the neighbors, we can just do graph node. And we can append the neighbor. But we need the path, right? We need to return the paths. So in our state here, we need to keep track of the path. And so the path first, starting from 0, has just 0 in it. And so here, when we extract pop, we get a path. And so here we need to add the neighbor, because we are just visiting this neighbor, so we need to add it to our path. So path plus the neighbor, right? Okay, and now so now that we have that for our queue, here we need to check if we reach the one we are looking for, our destination, which is n minus 1. So how do we get n? N is just the length of the graph. Because each slot is a node, and so to get the number of nodes, it's just the length, right? So if it's equal to our destination, then we want to add it to our list of paths. We want to add this path here, right? This path here. Because this path is from 0 to n minus 1, right? And we need to define, of course, a list of our paths that we return at the end. And so that should be pretty much it. We get the paths, and then when we find it, we return. You may ask, why don't we maintain a visited set and just check that we haven't visited it before? Well, because the problem says that this is a directed acyclic graph, so there is no concern of there being a cycle and getting in a loop in a cycle. So it's not possible, because it's said here that it's acyclic. So let's try this. Let's run it. And let's submit. And it passes our test cases, okay? Okay, so that was the BFS version. Now let's quickly do it with DFS. So we still need the paths here, but we just need to start our DFS from a node, right? And we need it, of course, the path as well. And so we need to start our DFS from the starting node, and path has first just the starting node, right? Now here, since we are modifying inside a function, we just need it to be a self variable here on the class. And here we just need to go through the neighbors in the same way that we did with BFS. And what we need to do here is just recurse. So instead of adding to the queue, we recurse, and so to the neighbor, and then the path we add neighbor because we just visited it, right? But here we also need to check that if we arrive it. So if the node is equal to n-1, we arrive it at our destination, then we want to add this path, right? So this would be self.path, right? And this path would have n-1 because we would have added it here before calling the DFS again, right? And again, here also we don't need visited set because of the same reason as for BFS. It's a directed acyclic graph. And that should be it, right? So let's run this. Let's submit. And that passes as well, right? Yeah, so that's pretty much it for today's problem. Please like and subscribe, and see you on the next one. Bye.